today's session of reflection of light, we'll look at some of the concepts of spherical mirrors, and also we'll look at the terminology that is used for concave and convex mirrors. So let's consider first what are concave and convex mirrors. Now these mirrors are actually a part of the spherical mirrors. So when you consider spherical mirrors, let's consider a sphere. Okay, so sphere is nothing but a substance, let's say like a ball, in which the shape is like a circle. Okay, so let's consider this as a sphere. Now there could be two cases. Either the internal surface could be a reflecting surface of the sphere, or the outer surface could be the reflecting surface. In case the internal surface is the reflecting, then in that case that is called as the concave mirror. So we'll just quickly draw a concave mirror here. So let's consider that this internal part is the reflecting surface. Now if we have another sphere where the outer surface is the reflecting, then this is the opaque part of it. So this surface is the reflecting. In this case, this is called as the convex, and this is called as the concave mirror. So concave and convex mirrors, we need to remember that these are part of the bigger spherical mirrors. Now let's look at the terminology. So first we'll consider what's a pole. So pole is the center of the mirror surface. So let's say if this is the reflecting surface and this is the mirror, let's consider this as the center. So this is the pole of the mirror, and let's denote it as by P. Okay. Now let's consider what is center of curvature. So it's pretty simple. The center of the sphere, okay, let's denote it by C. The center of the sphere is called as the center of the center of curvature. Now, if you want to define, you have to be very specific in saying the center of the sphere of which the mirror is a part. Okay. And next is the radius of curvature. So let's consider this line. So this is the radius of the sphere. So again, the radius of the sphere, okay, this sphere of which the mirror is a part is called as the radius of curvature. So here if we consider this as CA, and let's consider this as well, both these are the radius, CA and CP. Next is principal axis. So this we define as the line passing through, okay, the pole of the mirror. So again, we already defined pole. It's the center of the mirror, and the center of curvature is called as the principal axis. So if we just extend this line, okay, and name it as, let's say, M here. So this is called as the principal axis. So again, the line passing through the pole of the mirror and the center of curvature is called as the principal axis. Now the next one is principal focus. So maybe I'll draw some separate diagrams to explain principal focus, but for now let's assume here the point F is the principal focus. So we'll just take that in some time. And the last one, let's say, is focal length. Okay, so the distance here, now this is the length. Okay, so the distance between the pole and the principal focus is called the focal length. Okay, and this distance is half the length of the radius. So in this case, what will happen? CF is equal to FP. So again, what is focal length? The distance between the pole and the principal focus. That's what we have already defined. P is the principal focus. So distance between this is called as the focal length, and always remember this distance is half the distance of the radius. So let's look at what is principal focus. Now principal focus would be different in case of a concave mirror and different in case of a convex. So let's consider first the concave mirror. Again, so a concave mirror is a mirror in which the inner surface is the reflecting surface. Okay, and let's also talk about what are incident rays and what are reflected rays. Okay, so this is simple. So let's say if I place an object in front of this mirror, okay. So let's consider an object which is placed in front of the mirror. Now from any object, there are numerous light rays which are passed and they travel in all sorts of direction. Now in case of principal focus, let's concentrate on the rays that are parallel to the principal axis. So earlier we had talked about, let's say this point P, which is the pole of the mirror, and a line which is passing through this is the principal axis. Okay. So all the rays that are parallel, so these are the incident rays. So any ray or ray of light that comes from an object is called as the incident ray. So these travel, let's consider the ones that are parallel to the principal axis and traveling towards the mirror. Okay, so these are incident rays. Okay, now all those rays that fall on the mirror do get reflected, and there's a specific angle of reflection by which the rays get reflected. So all these rays that get reflected are called as the reflection rays. Okay, so from each of these principal axes, we're just drawing the reflected rays, and all these reflected rays, okay, they meet at a point. Let's consider this as F. All these rays, the incident rays which are parallel to the principal axis, they all get reflected and they meet at the point F, and this F is called as the principal focus, and the length FP is called as the focal length. So this was in the case of concave mirror. Now if we consider as convex mirrors, what happens in the convex mirror? So let's say this is a convex mirror where the outer surface is the reflecting part. Again, if we place a source of object here, all the rays, so again this is the principal axis, this is the pole, so all the incident rays that are parallel to the principal axis, so all the incident rays that are parallel to the principal axis, so let's say this is the principal axis, and yeah, let's name it as PM, okay, and all these are the incident rays which are parallel to the principal axis. In case of a convex, they all get reflected in different directions. Okay, so this is the reflected ray. Okay, so all these get reflected. Now so here we can clearly see that all these reflected rays do not meet at a point. But if we extend these rays further behind the mirror, all these rays meet at a specific point. Okay, and if we extend this, here is the point where all these rays meet. So let's consider this as F. So this F is called as the principal focus in case of a convex mirror. So it's clear that in case of a concave mirror, the principal focus is in front of the mirror. But in case of a convex mirror, the principal focus is behind the mirror, because all these reflected rays, they meet at a point which is behind the mirror. Friends, thanks for watching Crack Problems. Don't forget to subscribe and press the bell icon to receive further videos. And yes, एक like तो बनता है.